Let's take a look at the next example. So the next example in section 3.5, we're once again given an implicitly defined function. It's x squared plus y squared equals to 25. And now this time we're asked to find the second derivative of y with respect to x squared. Again, just in terms of the algebra, I find it a little bit more convenient to use the prime notation. I think it's just kind of visually a little bit easier to look at when you have it all together. So I'm just going to use the prime notation. So essentially we want to find y double prime. So to begin, let's start by finding the first derivative. So we're going to take the derivative with respect to x at both sides. We get x squared plus y squared. And this will be equal to the derivative of the right-hand side, which is 25. The derivative of x squared plus y squared is going to be 2x plus 2y y prime, and this is going to be equal to 0. We now want to get the y prime by itself, so I can take that x term over to the other side, subtract 2x from both sides. You would get 2y y prime equals to negative 2x, and then from there you would divide both sides by 2y, divide by 2y, these cancel, and so we get y prime is equal to, the 2's cancel, and we would get negative x over y. So just like we've been doing, we were able to find the first derivative, and we found that y prime is equal to negative x over y. So that's great, but we want the second derivative, and we know that the second derivative is the derivative of the first derivative. So let's go ahead and take, once again, the derivative with respect to x of both sides. If my iPad wants to cooperate. There we go. On the left-hand side, the derivative of the first derivative, well, that is the second derivative, equals. Now, on the right-hand side, we're trying to take the derivative with respect to x of negative x divided by y. That's a quotient, so we need to use the quotient rule. Recall the quotient rule says we need to do the derivative of the numerator. The derivative of negative x is negative 1 times the denominator minus the numerator, so minus a minus x, times the derivative of the denominator. The derivative of y is y prime, and this should be all over the original denominator squared, so over y squared. So we have that y double prime is equal to negative y plus x y prime over y squared. And seemingly it might look like we're done here, but there's just a little bit more to do, because even though the second derivative will also be implicitly defined, we don't want to have the second derivative dependent on any previous derivatives, meaning we really kind of want to eliminate this y prime term. Ultimately, the goal is to write the second derivative as an equation that equals stuff involving only the x and y variable. So what we're going to do is we need to make a substitution here. If you recall, we remember what the first derivative was equal to. Y prime was equal to negative x over y. So what we can do is everywhere we see a y prime, I can replace that with negative x over y. And now I have the second derivative expressed only in terms of x and y. I do want to simplify this a little bit, because right now this would be a complex fraction. To simplify that complex fraction, let's multiply top and bottom by y. This is going to be equal to, so if I distribute it into the numerator, negative y times y is negative y squared. Here, these would cancel, and I'd have negative x squared up top, and then all divided by y squared times y would give us y cubed. So there you have it. The second derivative is going to be negative y squared minus x squared divided by y cubed. Let's take a look at example 7. In example 7, we're asked to find the equation of the tangent line to the graph of x squared times x squared plus y squared equals to y squared at the point square root of 2 over 2, comma, square root of 2 over 2. So the object we're looking for is the equation of the tangent line. We know from algebra that the equation of a line is y minus y1 equals to m, it's a horrible looking m, there we go, m times x minus x1, where we have the coordinates x1 and y1, and the slope we know is going to come from the derivative. So let's go ahead and begin by finding the derivative of this one. And it's actually going to be helpful. So if we try to take the derivative immediately of both sides, we would quickly look at this and realize, oh, wait a minute, that's going to be a product rule. Let's take this extra step of rewriting this first. Let's distribute the x squared in. That would give us x to the fourth plus x squared y squared equals to y squared. And now it's going to help us to avoid that first initial product rule. We can take the derivative with respect to x on both sides. On the left-hand side, the derivative of x to the fourth is 4x cubed plus, this will be a product rule, the derivative of x squared is 2x, leave the y squared alone, plus now leave the x squared alone. The derivative of y squared is going to be a 2y y prime. It's equal to, on the right-hand side, the derivative of y squared, again, is 2y y prime. So far, so good. Our next step is to move all of our y prime terms to one side, and I'm going to do so by subtracting this term. This is really a negative 2x squared y prime term, just kind of reorganizing the variables. So we're going to subtract that term from both sides. We would have 4x cubed plus 2xy squared. These cancel. Is equal to 2y y prime minus 2x squared y prime. The next step is we have a y prime as a common factor on the right hand side. So let's factor out the y prime. So we factor our y prime out. And now we can divide both sides by that factor. So I can divide by 2y minus 2x squared y to both sides. This will cancel. And what we have is the following. Y prime equals, and when I write this down, notice that every one of these coefficients is divisible by 2. So let's go ahead and divide that out. In simplified form, this is going to be a 2x cubed plus x y squared divided by y minus x squared y. So everything looks good. Let's now go ahead and find our slope by evaluating this at the point square root of 2 over 2, square root of 2 over 2. So everywhere, and I'm going to need a little room for this. So we have 2x cubed. I'll plug it in up here. So we're going to have 2 times the square root of 2 over 2 cubed plus the square root of 2 over 2 times the square root of 2 over 2 squared divided by the square root of 2 over 2 minus the square root of 2 over 2 squared times the square root of 2 over 2. Alrighty, so now we're going to have a little bit of fun with arithmetic here. So we can do this. Let's see if we can figure this one out. And I'm going to do it perhaps in maybe an unconventional way, but if I multiply these two together, these last two terms in the numerator, that's multiplication by like basis, so you would add the exponents. Okay, I think most of you would probably just like work out the powers for these. It's cubed. In the denominator, let's see, what's the best way to do this? Blah, 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 blah. Again, this might not make any sense to you, but I'm just trying to do it without using a calculator. You can factor out the square root of 2 over 2. That's going to leave me with a 1 minus the square root of 2 over 2 squared. That's going to be square root of 2 squared is 2, and then 2 squared is 4. So this would be 2 over 4. This is equal to, in the numerator, I have 2 radical 2 over 2 to the third, plus another 1 radical 2 over 2 to the third. That'll give me a total of 3 radical 2 over 2 to the third powers, divided by, in the denominator, 1 minus, this is essentially a half. 1 minus a half is a half, and that's times a radical 2 over 2. This is equal to, so 3 divided by a half, keep change flip. 3 divided by a half will give us 6. And then for this thing, division by like basis, you subtract the exponents. This would become the square root of 2 over 2 squared, which is going to be 6 times 2 over 4, which is a half. And so we get a slope of 3. So at the end of the day, if you work that all the way out, you should find that the slope of that function is 3 at the point. And now once we have the slope, we have the point, it's simply a matter of plugging it into the point slope formula. So let's go ahead and do that. It's y minus the square root of 2 over 2 equals 3 times x minus the square root of 2 over 2. We can put it in slope-intercept form if we wish. Distribute the 3 in. This is going to be a 3x minus 3 square root of 2 over 2. And now add the square root of 2 over 2 to both sides. We get y equals 3x minus 3 square root of 2 over 2 plus the square root of 2 over 2 will give us 2 square root of 2 over 2, which is simply going to be the square root of 2. And there you have it. That's going to be the equation of the tangent line to the curve at the point radical 2 over 2, radical 2 over 2. It's a straight line that has a slope of 3, and its y-intercept would be negative square root of 2.